Hello everyone and good afternoon and welcome to this webinar where we will show you what's new in SCIA Engineer version 19.1 which was released a bit more than a week ago. My name is Vladimir and I will start this presentation, and together with Jaroslav Broš we will cover multiple topics. To start up with some housekeeping, all attendees are muted during the presentations. However, you are able, and I encourage you to do so, to use the questions box in the GoToWebinar application to ask any questions, and we will do our best to answer them, or you can even then send us emails if you feel that some further questions needs to be answered. Furthermore, this session is recorded and the webinar will be posted on SCIA YouTube channel for further use or for any sharing between colleagues or other people. If any information you find just brief, because we have a lot to cover and we have only limited time, there is a lot of information and descriptions available as part of the library of technical articles in our resource center. So please, if you have any questions or anything is unclear, you can read much more in depth the features that we are going to present today. What is going to be our agenda today? In version 19.1, we still keep the motto of version 19.0, which is design accelerated, and we make some further enhancement in concrete design, in aluminium and steel design, in general usability and analysis, and also in the terms of interoperability. We will share these topics with Jaroslav, and we will start with concrete. So in concrete, we made some improvement in the check of 1D members, and this improvement is connected to the ability of anyone to run all checks that are available on 1D members, all ULS and SLS checks, all at once by hitting a single button. In this case, to be refresh, but you have to, under the 1D member, select that you want to run the overall check. If all or only some of the checks has to be carried out, and all the checks will be executed at the same time. So you don't have to execute one by one to and you are able to see which check is failing or which are okay all together in a quite nice output. The benefit of this would be if you imagine a workflow when you first design your reinforcement on 1D members. So the design of reinforcement is shown to you in a way that you can see the amount and diameter of the required bars for the 1D members. You can convert these required reinforcement into real bars that will be displayed as user-defined reinforcement in the model, and straight ahead you can execute the overall check, and you will see all different kinds of checks that were enabled and the overall verification with the corresponding value. So the workflow in this case was streamlined, and it's really something that takes single or two clicks to achieve, even for bigger structure. What we also is the automatic SLS combination, because some SLS checks require characteristic SLS combination, where other checks, for example, in this case, the stress limitation check, requires quasi-permanent load combination. So in this case, if we are running multiple checks at once, and we have only one combination in the set in the properties. The all other required combinations are created automatically by the check and are used accordingly. So if you run your check, you can see that even though in the properties you have, for example, characteristic combination, you can see in the output that let's say checks that are to be calculated with the characteristic combination are run with the characteristic combination, and whether some other requires quasi-permanent or frequent combinations, these are carried out as well automatically. So this reduces the amount of necessary running of the checks for separate combinations, because all the SLS checks can be carried out together. 2D design and its improvement. If you imagine a workflow that was necessary in previous version, that start with calculating the required area of reinforcement, that basically shows the maximal amount of reinforcement in millimeters square per meter. These are then converted to provided reinforcement, which is combination of the basic reinforcement and additional bars that cover the extremes of the required reinforcement areas. And then when this diagram of provided reinforcement is available, you are able to run the check for crack width. And shall the check for crack width be insufficient, you would be required to go again and to increase the amount of the provided reinforcement. In the version 19.1, this is no longer the case, because as I told you about having a single click check for 1D members, we have something that is very close to it in and it's basically design of reinforcement of 2D members in one click. So again, very similar. You can check all or only ULS check, or sorry, design to be carried out, and if you check multiple, you will of course get design of provided reinforcement that is according all the combination of all of these checks. The important thing is that here we are mixing ULS combinations with SLS combinations. So you can see here that there is a class of combinations that is necessary to carry out this design, and this class should contain all of the following ULS and SLS combinations. So for each check, correct combination is provided in the class. How does this look if you have a look at the design of cracks together with the ULS check? So here you can see well, design of reinforcement in one direction, and you can see here are big areas where the bottom reinforcement in this direction is required, and you can also see some additional parts that require reinforcement based on the SLS crack width checks. And you can display, as I showed on the previous slide, you can either show all these checks or all these required reinforcement design in a single image, or for example, you can only see which is the additional reinforcement designed based on the crack width. So here we can see that parts that are common in both diagrams are not based on the reinforcement design from the bending moment, but they are from the crack. More, how this can be used is imagine a case where you would like to define some more severe criteria, let's say for the stress limitations. You can set up in settings with that you want to limit the reinforcement stresses to, let's say, 200 megapascals. And if you do that, you will well, as this criterion is more severe, you will be left with more reinforcement necessary to be added to the slab to fulfill this check. To sum this up, you will see both of these checks, or all checks, to be available in a brief table. You can clearly see which reinforcement is based on the ultimate check or ultimate design, and which are based on the serviceability design, as are again here drawn those based on the crack width check. And again, or furthermore, you will also have the detailed output where the SLS checks or SLS as well. As next topic is that back to the crack width. You can see here the check of the crack width. You can look and, let's say, have a drawing of the crack width, and again either brief summary of the mesh elements in this case according to this check, and you can also have some detailed output available as the outcome of the design. Next topic that is connected to 2D reinforcement design, but it's from a bit another view, is improvements in punching. We made two improvements in 19.1. Is the possibility of reduction of punching forces in foundations. Imagine a case where you have a base plate that is supported by surface support, and there are some columns that are connected to this foundation plate, and there is big concentration of contact stresses underneath the column. In version 19.0, no reduction was possible, but in the version 19.0, the reduction is based by the control parameter, and the area that falls within the respective control parameter is then taken care of as delta VED, which is the reduction of the punching shear force, and this reduction is also displayed in the output of the check. For those of you who wouldn't like to use this feature, it's a possibility of using the check without the reduction, and thus having quite conservative approach without the reduction taken into account. Second improvement in punching is regarding the punching check for columns that have modeled subregions over them. In previous versions, the working with subregions over the columns, let's say for column heads, was problematic. We introduce the possibility of taking the thickness of the subregion into account for the concrete crushing check in punching. So not yet for the reinforcement, but we started with the concrete crushing check at the very point of the connection between the slab and column. Ways from concrete topic of this presentation is that currently we have one-click solution for concrete in both 2D member design for both ULS and SLS together, and also one-click solution to check 1D members and all the checks that are available there. And the third topic is improvements in punching design. So this is end of concrete section, and I hand over to Jaroslav, who will show you improvements in steel and aluminium.
Thank you, Vladimir, and greetings also from my side. And I will start the sharing of my screen to be able to present you also what we did for steel and aluminium structures. I will start with the aluminium structures, where we did an update of the code which we had implemented in the past, and we also enable it in default post-processing environment. Let's a bit talk about what's inside of this, let's say, code update and the migration. There is an addition of some addendum, which is marked as here. And you can see also all the formulas where this A2 is written. And so that as it was published, it has some major influences on some, let's say, part of the check, or the parts of the modeling. And the major influence it has on transverse welds, on calculation of effective section, and also on the results, or on the calculation of check in the section, and also the stability checks, plus also some interaction checks. When we are talking about the influence on transverse welds, let's talk about this, let's say, simple example of the column created from the aluminium. And here you can see that I create a check with this value. Once I will play a bit with member check data, and I will add transverse welds into that columns, then because of the implementation and the usage of the addendum, which was published in 2013, it has an influence on the value of the check. What we also did in the case of the aluminium, it's that we did the improvements of the output, and also the calculation of the effective section, so that here it's a new dialog with the possibility to see the all iteration steps which have been used inside the classification tool. So you can see every step in the classification routine, how it was calculated. What we also did, and I'm showing it here, that you can see the 3D model, and then if you switch it for 2D FEM calculation, you can see also the pictures of the shear stress, and also some other parameters which are calculated inside the cross-section tool. And here you can see also some initial shape and the effective section calculated. So that's what we did, let's say, on input side related to the cross section, that you can model such a complex shape of the aluminium cross section. We also implement the addendum to all the aluminium checks, and what we also did, we also had an improvements in output, so that you can see all the formulas which are used on the background during the calculation of the check, as you are used to from steel check. So if you have some doubts how something was calculated, you can just go to the detailed report and see which formulas have been used, and you have also the possibility to see the reference, which is going directly to the Eurocode 9 with a specified chapter inside. We have been also looking at some improvements that you need to have some overall view how your check look. So we concentrated to create the summary output, which could fit one page A4, where we include all the design summary, where we include the information related to the combination key, appropriate internal forces, also the classification of cross section, how it look like, which class for the cross section will be used in checks. Then we have also the summary of all checks which have been done. Then the buckling parameters, which will be or are used for the stability checks, and at the end there is a summary of error or warnings or notes which have been appeared or are appearing during the sequential checks or sequential design. So that what we did for the improvements of output, that it should help you to more orient in our output, and that you should be able to easily find the informations which you need to have. And what I didn't yet mention, it's that we have also some improvements related to the graphics in 3D window. So we add also the legend into the 3D window for the results, so you know that you are using or you are just checking your structure for ultimate limit states, which value is drawn on a screen, which extreme, etc. is used. We also add the possibility to display the warnings or errors as in tooltips if I hover on the abbreviation. And we also added the option to draw all the components of the checks on a screen. And moreover, in the case of the table results, if you double click on some value in a cell, you will get a window with detailed output related to the value which is calculated. That's for example, if I will double click here, I will get an information about the unity checks, which is calculated in the position of 0.9. Moreover, when we have been so focused on the usability of our aluminium check, we also add the possibility to add the information related to the cross-section informations inside our engineering report. So you can get an information about the cross section here into your final report. That was very briefly related to the aluminium check. So as a recap, we migrate our functionality of aluminium to the default post-processing environment. So it means it's also usable in 64-bit version. We did several improvements related to the output, which increases the usability of the solution. What I would like to also share with you, and that's connected, and that's the steel camber design that's related to our release in 19.0 for steel structures. What we did here, that's mainly also the ability to, let's say, define the shape of the camber, because we have been asked that, well, the creation of the parabolic camber may be so costly that you are preferring to just cut in the middle and do the bilinear camber. So that's it's also possible to use for the camber this let's say triangular shape where you can just in the system length and buckling settings just you can switch from parabolic to bilinear and then set the value of the camber. What's also have been added to the 19.1, that's the ability to design the camber, so that if I have the continuous beam and I'm doing the SLS serviceability limit check without camber, then I have the problems in these areas where I have unity check 1.85, which is not satisfactory and it's red. I need to do something with it. So I can decide that I will use the camber design, and the SCIA engineer will design the camber for me based on some limitations which I set in the menu, that for the minimal camber will be 10 millimeters, the maximum will be 10 centimeters, and that the automatic, let's say, the design routine should round camber to value of 5 millimeters, so I can use just 10, 15, and in a row with a 5. If I will apply it here, so based on my settings and on the automatic calculation on the background, I will get much better results, if I may say, here for these members where I need to use the camber. And here I have also the possibility to see the value of the camber which I should use to get the results of this check equal to 0.96. And I can also, let's say, decide that I'm prescribing the limit of the camber in absolute value or as a percent of the dead load for the deflection. That's currently all from my side, what was related to the aluminium or to the steel. And now we are going back to the Vladimir's part, and it will be about the usability and what we did here.
Okay, back to me then. I will show you a few features that we developed overall, the software, and I will start with improvements in the engineering report. The first improvement is that we enabled scales for model image like this. You input it in the engineering report from the scene, but you feel that the supports are in this case too small to see. It might happen, or even other add data. So every picture now has a property in the engineering report with scaling, so you can just quickly well, write different value, and all the images, even selection of images, will get a different scale for model data as you would expect. And one remark here is that if new images are added, it's basically consistent to what we have here in version 19.0. The scales were used from the 3D scene, but you are able to change them in the dialog before inputting. Of course, you can change those afterwards. The same is applicable for results. So especially if you use the result picture generator, then you had before very little possibility to change the scale of the results. Now the image that contains any results, including the result picture generator based images, will actually have automatically identified the value of scale for results, and of course you can again change this scale, and all the images in your selection will well have this scale change applied. So these are small improvements in the engineering report. Let me show you some enhancement that we done in the analysis part. First feature that we introduced is the Singularity Check for nonlinear analysis. Imagine here, in this case, I have deliberately created a structure that is where the bending moment is actually exceeding the maximum bending moment that is defined by, in this case, hinges on a beam. And when I run the analysis, it will get to the plastic behavior of the hinge, and you will be left with the message that stiffness matrix is singular in the nonlinear analysis. However, you will receive feedback to be able to fix the structure, because as it is in the case of the linear analysis, even before version 19.0, you get an animation window where you will see what is the cause of the singularity. So even for the nonlinear analysis, we now give such feedback. Another improvement is regarding modification of soil parameters for seismic analysis. This is quite something, I would say, high-end for seismic analysis, but it is based on our research and on communication with clients that for seismic analysis, if you have soil, it behaves stiffer by a coefficient that is, or its value is varying between, let's say, 3 multiplicator 3 to 10, and it's based on the soil type of the subsoil. So in version 19.0, if you have soil analysis and you have a seismic load case, you are able to change these requests, change these values over by enabling stiffness multiplication factors from for the soil parameters and soil stiffness. And yeah, as mentioned before, it is for soiling, and if you have support type soiling which is used with seismic load cases, because the stiffness of the subsoil when you don't use soiling is actually something that you can use, or that you can vary by hand. So here there are those factors from the reference table, and you can incorporate both horizontal or vertical stiffness multiplication in the solver setup. How this influences the result? Here I have some building, and when the soil was with the basic stiffness, it had big deformations, but when the soil was, as indicated, provided with greater stiffness, and to comply with the analysis of the higher frequencies, the soil behaves stiffer, and the deflections are smaller accordingly. What we further enabled in post-processing environment default are pressure-only 2D elements. Those are special nonlinear elements that has the nonlinearity press only, and here you can see the comparison between the results of two very similar structures. On one is used on its top edge of the wall is used the nonlinear hinge, again with compression only nonlinearity, where in this case we have the press only 2D member set as a nonlinearity of that the results of the deformation in this case are identical if we have these the wall in tension. If you use the nonlinear hinges that were presented in version 19.0, you will actually get quite nice decoupling or unconnection between the wall and the slab if it is in tension, where in the 2D press only element you will get just the correct behavior, but the element will be with very little stiffness in tension, so it will basically show deformation like having no tensile stiffness at all. It will not create forces in the wall, and the slab is going to be deformed just the same way as in the case of nonlinear hinges. If we have if we compress or if we have the negative effect as on the previous case, you can see that in compression both cases are loaded as expected. Next area of improvement came from improving integration member. Integration member is an element that was introduced in version 0, and it is basically very useful to integrate internal forces in 2D element in a way so you can see the internal forces like they would be on a beam. Here I have two examples, building with cores or a bridge which is modeled with 2D members. What we did as a first enhancement is that we can now when compared to version 19.0, we are able to define number of sections per each integration member. So first, this is now a property from the integration member, which is very handy because it's post-processing feature. So changing this doesn't delete any results. You are able to change any properties of the integration member and you will not lose results. So you can change the number of sections on any integration member to get even the most integrated sections as you would like to. So it's based on your choice, and as I mentioned, it does not delete results, so you can use it quite quickly. Another feature for integration member is that now you are able to indicate where the centroid of the center of gravity of the integrated volumes is located, and you are able to integrate the forces in accordance to this position. So in the first case, you can see that the integrated internal forces are integrated and drawn in the respect of the reference axis of the integration member, which is straight, and in this case it's on the top level of the deck. If I change here the property to integration relative to center of gravity, the center of gravity axis is then investigated and calculated automatically, and also the internal forces are integrated correctly. This, of course, is important if you want to have correct values of normal forces and bending moments that are integrated to centroid. So in the first case, you would have some additional normal forces from the eccentric bending moment, but in this you will get much clearer results that are further usable in applications that you might use for it to investigate the results on integration member. What we are further able to do now is we can exclude members from integration. Imagine here in this case, we have the bounding box of the integration member, and everything that is within the bounding box got integrated into the internal forces in the version 19.0. In this case here, you can see that there are some bearings that got integrated along. So you can see there is quite a jump in the centroid axis if in this location, and it's caused by the bearings. If you select that you want to have the selection to have the user defined, you can exclude some members from the integration and have the internal forces being shown without these members. Let me show you another approach. Another approach for this feature. Imagine that here I have a multi-story building and I have stiffening core and some other stiffening walls, and I would like to avoid the total bending stiffness carried by the walls only from, let's say, wind action. So I want to exclude all the columns. I'm able to do that, and then I'm able to see the bending moment from the wind action on the shear walls in the structure. Small feature that is sometimes important because currently we don't support integration member results in checks. So there is some interoperability necessary. We support the XML output for both the definition of the integration members and also the results. So the results and the definition together can be used for any external use that you can imagine or you require such results for. And this is all from me. So thank you for attention, and I hand over again to Jaroslav, who will tell you something about 3D wind and interoperability.
Thank you, Vladimir. And let's start something which is also close to the usability in a point of view of the loading. We did also a couple of enhancements in our wind load generator. The first thing which I would like to share with you, that's the possibility that you can consider the correlation between the zones D and E, as it is written in the following annexes. It's valid for standard, Belgian, British, Dutch, Finnish, French, Slovak, and Czech. So if you are, let's say, designing the structure in one of these countries, you can use this enhancement or this capability to consider the correlation between these two zones. If you are designing the structure not in these countries, or you are not using the standard national annex, then you are not able to use it because it's not in the setup manager. So that's very, let's say, the very easy approach. As a default, it's enabled. You can disable it. What we also did, that we receive some questions that we may missing some load cases for dual pitch roofs. So we have a look at it, and we came up with this solution. So you have these two, let's say, load cases mentioned in the Eurocode, that they are describing the state for the dual pitch roofs, where you are combining the external pressure. And I think that you are familiar in our wind generator with this dialog. So we simply just add the option here, the additional load cases for dual pitch roofs. You can just click on the checkbox, and then what you need to is to consider the direction of ridge or throat of the roof, if it's in direction of x-axis or in direction of y-axis. If you have some, let's say, more difficult or a bit complicated structure like T or L, you can choose what I have here now, that I would like to apply this possibility in both directions, so that I have generated these load cases for the dual pitch roofs which I have in my structure. That's very simple. By default, it's switch off. You need to take an action and switch it on, and that's just valid for the dual pitch roof. So if you don't have dual pitch roof, like mono pitch or flat roof, then you don't need to consider this option. So a small enhancement, what very useful to have it. What we also did as an enhancement of our solution, and let's say the continuation of the development which we did, and it was related to the parapets. That's also the application of the French National Annex for parapets. Here I'm mentioning the cases where it is applied, and also the values of the coefficients of CPNet. So if you are in France and you are using the French annex, it will be applied automatically based on the settings of the annex. That was all from my side related to the loads, or the generation of wind loads, and related to the usability. I am going over to the topic which is related into the interoperability, and mainly that's the term which we are using more generally for connection with the other softwares, and also with our API. I will start with our BIM links. And first of all, I would like to share with you the development which we did in the Tekla link. We enabled the possibility to define or to transfer the opening from Tekla to SCIA Engineer, so that I have a steel hole with some concrete part with 2D slab, and the opening is created, so I can just run our plugin, and I have a model with the opening also in SCIA Engineer. In SCIA Engineer, I can add another opening with, let's say, the triangular shape, and I can do the update back to the Tekla. So in that case, that's a bidirectional exchange of informations about the opening, and I'm able to create any shape of the opening. So that's the benefit that you can use, let's say, more information during the transition of the model from one application to the SCIA Engineer. What we also did, and that's related to the 19.0 and also the Revit application. As you know, in 19.0 we published, developed the possibility to convert the design reinforcement into the real bars, so that now we are able also to exchange this information inside the Revit link, so that you can do the model in Revit. So I create this simple model, combine the concrete and the steel in Revit. I need to do some global analysis, so I export model to SCIA Engineer. I run the global analysis. I do the design of reinforcement in a concrete, and then I just push the button, as it was also described previously by Vladimir in his talk about one-click solution. So I just push the button. I have here the reinforcement generated based on my design. What I still need to do is just push the button in our Revit link, just update the model, and I have the same reinforcement which is in SCIA Engineer also in Revit, and I can do the detailing as I'm used to in Revit if I'm doing it in Revit. What is also possible is that you can combine the conversion of the reinforcement with the input through the reinforcement in SCIA Engineer. So I can have, let's say, the both type of the reinforcements, and I can export them into the Revit. In the case of the practical reinforced automatic design, is that we are applying the same limits also in the case of the export from SCIA Engineer to Revit. So that's, we are using the same limits. Once we have been talking about the interoperability, it's not just the connection with the Revit or with Tekla in the name of the BIM, but also we released in 19.0 our open API, and currently we are doing also some enhancement of this functionality. What's new is that currently you are very easily able to define the line load, define the line support, define the type of the constraints for the nodal support, that for example in X direction or Y direction it's rigid, the rotations are free, etc. That's possible. What's also possible in the case of OpenAPI is that you are able to define your open combination within your application, send it to SCIA Engineer as a part of the model, as I have it here, and also after the end of linear calculation, which could be done directly from your application through the OpenAPI, you can also get the results back for the combination which you created, as I have it here. So if I will run the calculation and I will ask results for combination C1, I will get all the results which are available without any settings of the extreme. So I will get all the results for all the combi keys which are in a combination. That was all from my side, which was related to the interoperability, and that was also all what we have prepared for you in the name of the What's New in 19.1. We have been speaking about the concrete, where we have been shown you how easy is to use 1D concrete solution with one click, that we are able to convert the reinforcement and do the overall checks for 1D, that we are able in 2D almost do the same, that we are able to design the reinforcement for ultimate serviceability limit state, and also for cracks and stress limitation. We did also some nice enhancement of our punching solution, mostly related to the foundation, as I remembered. Then we spoke about the enhancements and upgrade related to the aluminium design. I have shown you the design of camber for steel structures. Then we switch our attention to the usability, where Vladimir presented a lot of things related to the solver, to the let's say the usability of integration member, and I finalize it with informations related to 3D wind and our interoperability features such as Tekla link, openings, Revit link, export of reinforcement, and also enhancement of our open API. So we are at the end of our webinar. I will just quickly have a look at our question box. It seems that all questions are answered, but if you have any other questions which will appear in your mind after the end of the webinar, you can reach us on our mails, which are published on the page with the informations related to the webinar. So thank you that you came, that you attend this webinar, and I wish you have a nice rest of the day. And once again, thank you very much. Goodbye.